Have you ever imagined this scene? You stand upon a tiny rock, surrounded by endless seas. How insignificant and helpless you would feel. You'd be overcome by terror. Your mind might even refuse to process it. Now fasten your seatbelt. I'm taking you to a place deeper and lonelier. We're talking about extreme distances, the fastest things in the universe, after billions of years, to traverse but a fraction of it. Now close your eyes and relax your body. Begin this wondrous journey. Tonight, we embark on an unprecedented journey of the mind. This voyage has one core objective: to completely reshape your understanding of size and distance, thereby rethinking the very meaning of existence itself. We typically measure the world in meters and kilometers, but after this moment, light years will replace them as your new mental ruler. We're accustomed to thinking on a human scale, believing cities are vast and oceans boundless. But all this will be utterly overturned. Our journey begins in a place you know intimately, perhaps your backyard, perhaps your windowsill, that seemingly ordinary space where you live each day. From there we'll take our first step, and you'll witness the awe-inspiring shifts in perspective. Together we'll leave Earth behind, surveying our beautiful blue home. Then it will swiftly shrink to a speck of dust. We will traverse our seemingly vast solar system, discovering it is far emptier than imagined. We will reach the nearest star and comprehend the eternal isolation this distance represents. Then we will plunge into our own Milky Way galaxy, seeking our place within this metropolis of hundreds of billions of stars. But we will not linger here, for beyond the Milky Way lie galactic giants that dwarf it. Our vision will continue to expand, seeing how galaxies cluster together, and how gravity weaves them into superclusters spanning hundreds of millions of light years. These superclusters form the largest structures in the cosmos, a vast neural network called the cosmic web. Its existence will make you fundamentally question how reality is organized. Ultimately, we will reach the edge of all known knowledge, the boundary of the observable universe. But the true end of our journey lies far beyond. We will challenge the limits of our own thinking. We will explore the origin and ultimate fate of the universe. We will confront the 95% of the cosmos that remains utterly unknown, dark matter and dark energy. We will even question the relationship between consciousness and the universe, and ponder whether our universe is merely a bubble within an infinite multiverse. When this journey concludes, you will gaze upon the stars once more, no longer feeling mere insignificance, but instead a profound sense of connection and wonder. You will understand that redefining size and distance is merely the first step in rediscovering ourselves. Now prepare yourself. Let us depart from this most familiar point and journey together toward the unimaginable unknown. Close your eyes for a moment. Recall the city where you live. Imagine the bustling streets on a weekday morning. Traffic flows like blood through the city's veins. Subway cars are packed shoulder to shoulder. Thousands of individual life paths converge in this moment. Behind every window, a different story unfolds. Every household experiences its own joys and sorrows. This vast conglomerate of steel, concrete, and glass stretches in every direction beneath your feet, reaching the horizon. Feels so solid, so eternal. Standing on the observation deck of the tallest building in the city center, gazing down at the crisscrossing streets and scattered buildings, you feel the majestic power of humanity. This city holds millions, even tens of millions of people. Each person carries a complete and complex inner universe. Here, hospitals welcome the first cries of new life. Here, schools nurture dreams for the future. Here, factories produce goods exported worldwide. Here, decisions may shape the economic pulse of the entire nation. This feeling is so real, so weighty. Now let us lift our gaze higher. Unfold a map of this country in your mind. The city you stand in instantly becomes a single point on the map. It is tightly connected by countless highways, railways, and air routes, like slender yet resilient threads, weaving together hundreds, even thousands of such cities and towns, together forming a grander whole. Your nation possesses a long history and unique culture. Its laws govern the conduct of hundreds of millions. Its policies determine the flow of resources across its vast territory. Its voice is clearly heard on the international stage. Across this land, mountains rise and rivers surge. Forests, fields, and deserts trace nature's contours. You may take pride in its vastness and diversity. Feeling it almost embodies the entire world. At this scale, your everyday city becomes a chapter within a grander narrative, and you a character within that chapter. Yet it still feels like the center stage of every story. The news we receive, the market fluctuations we track, the festivals and traditions we celebrate, most revolve around this social entity we inhabit. This tendency to anchor our worldview in our immediate surroundings is deeply rooted in our evolutionary history. Our ancestors needed only to grasp the boundaries of their tribe and the range of their hunts. Our brains are inherently optimized to process information at this scale. We instinctively measure distance with our footsteps, perceive time through the cycle of day and night, and construct society through kinship ties. This human-centered perspective naturally fosters a sense of centrality, as if the world radiates outward from us as its origin. The skyscrapers we build stand as monuments to human ambition. The borders we draw symbolize civilization and order. The satellites we launch extend the reach of human technological prowess. All this silently reinforces an underlying belief that we humans are the measure of all things, that our place is the center of meaning. Yet this may merely be a fleeting fragment in the vastness of time and space, a grand illusion crafted by our limited senses. This illusion is so vivid, so convincing, that we seldom question its absolute truth. But today, we will consciously burst this comfortable bubble. We will depart from this center we deem familiar, to examine its true position within a grander context. Carry with you this sense of everyday scale. Remember what you now perceive as vast and solid. For we are about to take the first step, to see how everything familiar begins to shift, as our perspective rises. Now join me in a thought experiment. Let us slowly lift off the ground where you stood just moments ago. Imagine riding an invisible elevator, ascending vertically. The speed increases steadily. First, you see your entire city. It rapidly contracts into a distinct geometric shape. Those streets you once thought boundless now transform into intricate, orderly patterns like circuit boards. The skyscrapers that once pierced the clouds now appear as minuscule components embedded within this circuit board. You continue ascending. The entire metropolitan area unfolds before your eyes, like an irregular cultural patchwork, attached to the vast natural landscape. Winding roads and green fields connect city to city. You begin to discern your nation's coastline, a clear and beautiful boundary between land and sea. You begin to realize that the homeland you know actually possesses a very specific and finite shape. It might resemble a boot, or a maple leaf, or a rooster. This nation you may never have left in your lifetime now unfolds completely before your eyes. It is no longer an abstract concept, but a geographical entity with distinct borders. But the ascent continues. The continent's outline grows ever sharper. You see mountain ranges like folds in the Earth's skin. You see rushing rivers like winding, luminous threads. You see vast deserts like patches of gold. Your country now becomes a part of this continent, It presses tightly against other nations, together piecing together the continent's complete face. From space, the borders between nations appear so artificial and fragile. They are the geographical projection of human political ideals, not divisions inherent to nature itself. Now you have entered the realm of space. Your vision is filled with the entire planet. This is a sight you have seen countless times in photographs, but strive to feel the awe it inspired when first witnessed by humankind. This vast world beneath our feet now appears as a sphere suspended in pitch-black void. Its entire form radiates a dreamlike blue, the color of oceans covering 70% of its surface. White, swirling clouds drift slowly through the atmosphere, imbuing this blue planet with dynamic vitality. You can clearly see massive storm systems spinning over the oceans, like a white top spinning merrily on its own. The once vast continents now appear as patches dotting the blue canvas. Brown, green, and white intertwine upon it. This is the famous blue marble. This is Earth, the shared home of us all. Now gaze upon it. Try to find the point from which we set out. Find the country where you live. Find the city where you reside. Find the street where you just stood. You will find it impossible. Every familiar geographical landmark has vanished. The magnificent city where you dwell, along with the joys and sorrows of its millions, can no longer be distinguished amidst this kaleidoscope of hues. All the roads you've traveled in your lifetime, linked together, scarcely form a discernible line on this sphere's surface. Every territorial shift and conflagration of war in human history have all unfolded upon this smooth sphere's thin surface. The achievements of our proud civilization, the historical relics we treasure, our personal epics woven with love and hate, viewed from this moment's perspective, none have left a visible trace upon this planet's surface. They are perfectly concealed beneath the macro scale. This planet floats silently, bathed in sunlight, half is immersed in warm radiance, while the other half lies cloaked in its own icy shadow, cares not for your recently concluded workday, nor for the elections unfolding in some nation. It follows the laws of physics orbiting steadily, as it has for billions of years. The world we once thought solid turns out to be a sphere traveling through cosmic vacuum. The home we once thought boundless turns out to be just one pixel in this grand canvas. This first leap in perspective has already begun to shake the foundations of our self-centered understanding. But remember, this is only the first step of our journey. This beautiful blue marble will soon shrink again, and we will face an even deeper emptiness. Now let us turn our gaze away from this solitary blue marble and look toward the broader space it inhabits, the home we call the solar system. In your imagination, the solar system might be a crowded picture, with the sun shining at its center, with 8 planets neatly arranged along distinct orbits, occasionally dotted with asteroids and comets. But this familiar illustration is a gross misunderstanding, an extremely compressed version for teaching purposes. The true solar system is far emptier than you could ever imagine. Let's build a more realistic scale model. Suppose we shrink the sun to the size of a standard basketball, its diameter roughly 24 centimeters. At this scale, Mercury, the closest planet to the sun, would be a grain of sand orbiting 27 meters away. This distance is roughly the length of a basketball court, and our Earth would also be a grain of sand in this model, orbiting the basketball-sized sun at 70 meters. This is about 3/4 the length of a football field. Mars would be 100 meters away. The massive Jupiter would shrink to the size of a grape, but positioned 350 meters away. Saturn orbits like a slightly smaller grape at 650 meters. The distant Uranus and Neptune lie 1.3 kilometers and 2 kilometers away, respectively. This is far from the end. The solar system's boundary isn't at Neptune's orbit. Beyond Neptune's orbit lies the Kuiper belt, composed of icy celestial bodies. In our model, it extends from 2.5 kilometers out, reaching as far as 7.5 kilometers. And this is still not the end. The true edge of the sun's gravitational influence is the Oort cloud, a spherical cloud enveloping the entire solar system. In our basketball sun model, the inner edge of the Oort cloud lies roughly 500 kilometers away, while its outer edge may extend as far as 10,000 kilometers or beyond. Now picture this scene. A basketball sits alone in the center of a vast field. Within its surrounding kilometers, only a handful of dust-like planets orbit around it, and between these sparse specks of dust lies an even vaster, almost empty space. Here, there are no connecting lines, no orbital markers, only a near-perfect vacuum. This is the true face of our solar system. It is not a crowded palace, but an endless desert. Those planets are like grains of sand scattered across a vast desert, separated by distances so vast they inspire despair. The speed of light is the universe's ultimate velocity, capable of circling Earth 7.5 times in a single second. Yet light departing from that basketball-sized sun takes a full 8 minutes to reach the sand-grain Earth, 43 minutes to reach the grape-sized Jupiter, and over 4 hours to reach the most distant Neptune. This means that at any given moment, the solar system is filled not with solid matter, but with photons and gravitational forces traversing immense voids. All our explorations, all our history, all our wars and peace, art and science, the birth and death of love and hate, all unfold upon a single grain of sand in this vast void, and upon another, smaller grain beside it, the moon. This is the stage for our entire story, a speck of dust orbiting a star in near absolute nothingness. Recognizing this may be the true beginning of your understanding of cosmic scale. Now let us take our first true step beyond the solar system. This step will carry us into the boundless expanse between the stars. Here, the kilometers we use daily become as insignificant as dust. We need a new ruler to measure this void. That ruler is light itself. First, grasp the concept of the speed of light. Light travels through a vacuum at 300,000 kilometers per second. This figure alone exceeds our everyday perception. Let's try to translate it into more intuitive terms. In 1 second, light could circle the Earth's equator 7.5 times. Light reflected from the moon reaches our eyes in just about 1.3 seconds. This is the speed of light, a near instantaneous cosmic limit. Now combine this unimaginable speed with time. Imagine a beam of light traveling at this constant, eternal speed through the vacuum for an entire year. The immense distance it covers during this time is defined as 1 light-year. Through precise calculation, 1 light-year is approximately 9.46 trillion kilometers. This is a colossal number composed of 9 zeros and the digit 46. An abstract concept our brains cannot directly process. Yet its significance is paramount. The light year is not a unit of time, but a unit of distance. It is a measuring stick crafted specifically for the vast ocean of the cosmos. Now let us wield this new ruler to gauge the distance between us and our neighbors. The closest star to our solar system is Proxima Centauri. It lies in the direction of the constellation Centaurus, separated from us by approximately 4.24 light-years. 4.24 light-years might seem like a comprehensible number, but let us reveal the breathtaking truth behind this figure. Let's revisit our familiar analogy of a car journey. Imagine driving a car at a steady 100 kilometers per hour, straight toward Proxima Centauri. How long would this journey take? Brace yourself. The answer is over 30 million years. 30 million years, a span longer than modern humans have existed on Earth. When you start the engine, our ancestors were still primitive Australopithecus. By the time you'd cover half the distance, Homo sapiens would only just be emerging from Africa. And when you finally reach Proxima Centauri's orbit, human civilization might have already witnessed countless cycles of rise and fall. This calculation assumes a mere 100 kilometers per hour speed. Our fastest launched spacecraft, Voyager 1, travels at 61,000 kilometers per hour. Yet even at this velocity reaching Proxima Centauri, it would still take over 76,000 years. This is the chasm that stretches between the stars. Distance creates a near-eternal separation. But the light year reveals far more than this. Profoundly exposes a core characteristic of the universe. The universe we see is not as it is now, but as it was in the past. For light from those distant celestial bodies takes time to reach us. When you gaze up at a star in the night sky, what you see is not its present state, but light emitted at some point in its past. This beam of light has journeyed alone through the cosmos for years, decades, centuries, even millions of years, before finally reaching your eyes tonight. The sun you see is the sun as it was 8 minutes ago. If the sun were to suddenly extinguish itself now, it would take us 8 more minutes to plunge into darkness and panic. The Proxima Centauri you see is as it was 4.24 years ago. And the brightest star in the night sky, Sirius, has been hurrying along for over 8 years to deliver its dazzling light. When we peer through telescopes at galaxies millions of light years away, what we witness is their appearance from the time dinosaurs still roamed Earth. Astronomy thus becomes a singular discipline, a science that observes history. Gazing into the depths of space is to peer back into the abyss of time. Each beam of starlight is a time machine, carrying secrets from the ancient past of the cosmos. We can never know the universe's present state. Confined within a light cone, we piece together the universe's story through this delayed information. This realization inspires both humility and a peculiar kind of romance. Our connection to the cosmos is forged through these ancient photons, messengers that bridge the chasm of time and space, whispering tales of primordial eras. Understanding light years and cosmic delays holds the first key to grasping the universe's scale. Next, we'll wield this key to unlock the gates of our own Milky Way galaxy. Now let us shift our gaze from our solitary solar system into a grander structure, our true stellar home, the Milky Way. Imagine a colossal cosmic windmill, or a luminous island slowly rotating through space. This is our Milky Way galaxy, a vast collection of hundreds of billions of stars. This shape resembles a flattened disk, with an ancient stellar nucleus bulging at its center. Several massive spiral arms extend from this nucleus. These arms are composed of bright stars and glowing gas, like vast cosmic rivers, flowing slowly around the center under the pull of gravity. Our solar system does not reside at the Milky Way's center, but lies within the inner portion of a spiral arm called the Orion Arm, a relatively quiet cosmic suburb. From our vantage point on Earth, this Milky Way stretching across the night sky is actually the side view of this immense disk. Countless distant stellar lights coalesce into a hazy band of light. Now let us grasp its scale. The Milky Way spans approximately 100,000 light-years in diameter. Remember this figure, 100,000 light-years. This means that even traveling at the universe's fastest speed, the speed of light, from one end of the Milky Way to the other, would take a full 100,000 years. When this beam of light set out, the ancestors of modern humans had just begun migrating out of Africa. By the time it finally reached the other side, we had long since developed civilization and launched into the stars. And this is merely a one-way journey. If a civilization at one end of the Milky Way attempted to send a radio signal to us at the other end, that signal would require 100,000 years to reach us. By the time our reply signal returned to them, 200,000 years would have passed. This distance creates a fundamental information barrier. Civilizations within the Milky Way may be like islands scattered across an ocean, separated by an abyss of time. Let's grasp this with a more intuitive analogy. If the entire Milky Way were shrunk to the size of the North American continent, then at this scale, our entire solar system, including the distant Oort cloud, would have a diameter roughly the size of a CD. The distance between Proxima Centauri and us would be equivalent to walking from a CD in New York Central Park to another CD in San Francisco's Golden Gate Park. Across this vast continent, scatter billions upon billions of such disk-like systems, most separated by kilometers or even tens of kilometers. This is the true density and scale of our stellar city. It is by no means a crowded stellar metropolis, but rather a vast domain with expansive uninhabited regions. Yet within the grand panorama of the cosmos, such a colossal system housing hundreds of billions of stars is not particularly remarkable. Through observing countless galaxies, astronomers have discovered that our Milky Way is merely an ordinary galaxy. It is neither the largest nor the smallest. It is neither the brightest nor the darkest. In form, it is a common barred spiral galaxy. In size and mass, it occupies the average range among galactic populations. The universe hosts numerous dwarf galaxies far smaller than the Milky Way, possessing perhaps only billions of stars. Yet it also contains true galactic giants, such as the previously mentioned IC 1101, with diameters reaching millions of light-years, and containing over 100 trillion stars, making our Milky Way appear like a speck of dust in comparison. Recognizing this is crucial, our home is neither the center of the universe, nor a uniquely special existence. It is merely one ordinary, commonplace member among the trillions of galaxies in the cosmos. This realization shatters any lingering sense of superiority we might cling to, placing us squarely within a vast and egalitarian cosmic backdrop. Yet our journey is far from over. This ordinary city of stars, the Milky Way, is itself merely an ordinary member within a larger cosmic social structure. Next, we will step beyond the Milky Way to observe how galaxies cluster together. Let us continue to gaze beyond the Milky Way. There exist true cosmic giants that dwarf our home. They are the giant elliptical galaxies. One of the most representative is IC 1101. Behind this designation lies an unimaginably colossal entity. If our Milky Way is a stellar metropolis housing hundreds of billions of inhabitants, then IC 1101 is a stellar supercluster encompassing hundreds of such megacities. Its diameter spans approximately 4 million light-years. This means a beam of light traveling from one end to the other would take 4 million years to traverse. Compare this figure to our Milky Way's diameter of 100,000 light-years. IC 1101 is 40 times larger than our galaxy, and boasts a volume thousands of times greater. Within this vast expanse reside approximately 100 trillion stars. Take a moment to grasp the magnitude of 100 trillion. It signifies the number 1 followed by 14 zeros. Our Milky Way contains roughly 200 billion stars, already an astronomical figure. Yet IC 1101's stellar count exceeds that of our Milky Way by more than 500 times. This quantity surpasses the total number of leaves in all the forests on Earth, and exceeds the combined number of cells in each and every one of your bodies. Imagine gathering all the stars from 500 Milky Ways and cramming them into a single space. What an intensely dense and dazzling spectacle that would be. This disparity in scale is overwhelming, utterly mind-boggling. If we liken the Milky Way to an aircraft carrier sailing the cosmic ocean, then IC 1101 is an entire floating continent. If we liken the Milky Way to a brightly lit modern metropolis, then IC 1101 is the combined radiance of an entire nation. Its form also differs starkly from our spiral galaxy. It is a massive elliptical sphere, without spiral arms, like an immense golden halo. Such a form typically arises from violent collisions and mergers between galaxies. IC 1101 likely grew to its awe-inspiring scale by devouring countless smaller galaxies. It is a cosmic monarch, ruling the central region of its galaxy cluster. Its very existence proclaims to us that the scale represented by the Milky Way is by no means the upper limit in the cosmos, but may even be merely a starting point. When we take pride in our home galaxy, let us not forget that in the depths of space, such silent giants exist. Their presence redefines the scale of galaxies and recalibrates our place in the universe. Recognizing galactic giants like IC 1101 is a crucial step toward understanding the diversity of cosmic structures. It reveals that the cosmos is not only vast, but teeming with extremes beyond our imagination. Yet this is still not the end of the story. Galaxies, regardless of size, do not float alone in the void. They are interconnected in ways we have yet to fully grasp, forming grander structures. In the grand narrative of the cosmos, stars are not born and die in isolation. They gather into galaxies, and galaxies themselves follow the same law. Bound by the invisible ties of gravity, they form the larger social structures of the universe. This is what we will explore: galaxy groups and clusters. They reveal higher levels of cosmic organization. Let us begin with our closest cosmic neighbors. Our Milky Way is not a solitary wanderer. It belongs to a small gravitational family called the local group. Within this space, spanning roughly 10 million light-years in diameter, over 50 member galaxies are clustered together. Within this family, the Milky Way and the Andromeda Galaxy are the two principal members. They are two massive spiral galaxies, orbiting each other in a gravitational dance. The Andromeda Galaxy is even larger than our own Milky Way. On a clear night, you might even glimpse a faint smudge in the night sky. That is light from the Andromeda Galaxy, traveling toward us at 400,000 kilometers per hour. In about 4.5 billion years, it will perform a cosmic-scale merger with our Milky Way. Beyond these two giants, the local group also includes smaller spiral galaxies like Triangulum Galaxy, and numerous dwarf galaxies such as the Large and Small Magellanic Clouds. Like satellite towns surrounding a major city, they collectively maintain this local gravitational equilibrium. The local group reveals that even galaxies cluster under gravity to form a miniature cosmic community. Yet the local group remains a minuscule unit within cosmic architecture. Expanding our perspective further reveals truly awe-inspiring cosmic metropolises, galaxy clusters. Among the most renowned examples is the Coma cluster, situated in the constellation Coma Berenices. This is an existence utterly distinct from our own local group. The Virgo cluster contains over 1,000 bright galaxies, and thousands more dimmer ones. Its total membership may exceed 10,000. This immense galaxy cluster is tightly bound by gravity, occupying a space over 20 million light-years in diameter. Imagine this scene. Within a single region of space, tens of thousands of galaxies of diverse shapes and sizes are densely packed. Massive elliptical galaxies stand like venerable nobles. Graceful spiral galaxies twirl like dancers in rotation. and irregular galaxies of all shapes and sizes dot the landscape. Its galactic density is thousands of times greater than our own local group. At the heart of the Coma cluster reside two supergiant elliptical galaxies, NGC 4874 and NGC 4889. Their immense mass is sufficient to influence the entire cluster's dynamical structure. These colossal galaxies stand as central landmarks in the cosmic metropolis, dominating this bustling stellar domain. Such concentrated mass fills the Coma cluster with fiery X-ray gas, reaching tens of millions of degrees. The X-ray glow emitted by this gas itself becomes a luminous beacon for this cosmic metropolis. Whether in our local community, the local group, or cosmic metropolises like the Coma cluster, their existence points to a deeper truth. Gravity is the architect of the universe. It shapes the structure of matter on the largest scales. Galaxy clusters are the largest self-gravitating systems in the cosmos. Their formation and evolution chronicle the universe's journey from its initial high-density state to the intricate tapestry we observe today. When we gaze upon a cluster like Coma, we are not merely viewing a collection of thousands of galaxies. We are observing the very fabric of the universe itself, understanding how matter under gravity's influence coalesces from near-uniform distribution into the magnificent hierarchical structures we behold. The existence of these galaxy clusters paves a solid path for our next exploration of the largest structures in the universe. They act as pivotal nodes in the cosmic web, connecting to an even vaster cosmic network. And that is precisely where we are headed next. Now, let us broaden our perspective beyond individual galaxy clusters into a more monumental cosmic hierarchical level, the supercluster. They are vast cosmic collections composed of numerous galaxy clusters and groups. Much like continents formed by nations and cities, the cosmic continent we inhabit bears the beautiful name Laniakea. In Hawaiian, Laniakea means endless heaven. This name perfectly matches its monumental scale. This supercluster spans approximately 520 million light-years in diameter. This figure demands contemplation. 520 million light-years means that even traveling at the speed of light, crossing from one end to the other would take 520 million years. Compare this timescale to Earth's history. Our planet is approximately 4.5 billion years old. When Earth first formed as a fiery ball of molten rock, a beam of light set out from one edge of Laniakea. It traversed the entire era when dinosaurs ruled the Earth, witnessed the rise of mammals, and observed the birth and development of human civilization. Yet even today, this beam of light remains on its journey, still not having reached the horizon at the opposite end. Within this unimaginably vast space reside approximately 100,000 galaxies like our own Milky Way. 100,000 galaxies, each galaxy contains hundreds of billions of stars. These galaxies are not randomly scattered, but flow along vast filamentary structures under the influence of gravity. Much like water flowing along mountain ridges to the ocean, all galaxies stream toward a common gravitational center, known as the Great Attractor, a massive concentration of mass we still do not fully comprehend. Now let us reposition ourselves within this supercontinent. You might naturally assume we occupy some central point, but the opposite is true. Our local group of galaxies, including the Milky Way and Andromeda, is merely a tiny speck on the edge of the Laniakea supercluster. We are not in the capital of the cosmic continent, not even in a significant province. We live in the cosmic suburbs, a distant, quiet outskirts. Imagine the Laniakea supercluster as a map of North America. Then our location, would roughly correspond to the Atlantic Ocean hundreds of kilometers off the east coast of North America. At this scale, our familiar Milky Way becomes smaller than a grain of sand, and the entire local group is but a tiny speck of plankton on the ocean's surface. This realization fundamentally transforms our cosmic perspective. The cosmic coordinates we once deemed significant pale into insignificance against this supercontinent's backdrop. The Milky Way we once gazed upon is but a faint speck of light in an endless celestial expanse. The galaxy clusters that once filled us with awe are here merely ordinary towns on the continent. This sense of marginality does not diminish our stature, but allows us to grasp our cosmic position with greater authenticity. We inhabit an ordinary region within an ordinary supercluster, in an ordinary galaxy within an ordinary group of galaxies, orbiting an ordinary star on an ordinary planet. This very ordinariness may hold the deepest truth. The physical laws of the universe are the same here as anywhere else. We are not special, but our ability to recognize this ordinariness is itself extraordinary. The next time you gaze at the night sky, remember you see not merely scattered starlight, but a corner of an endless paradise, a cosmic continent 520 million light-years wide, and you stand on its quietest outskirts, gazing upon its profound beauty. This realization may bring you a peculiar calm, allowing us on this cosmic scale to find our own humility and peace. When we stand at the perspective of the Laniakea supercluster and believe we've reached the pinnacle of cosmic structure, a grander, more fundamental pattern slowly emerges. It is called the cosmic web. This is the ultimate pattern of the observable reality within humanity's current observational capabilities. Imagine something in your mind, not a planet, not a galaxy, not even a star cluster, but a neural network so vast it defies description, much like the intricate web of synapses connecting countless neurons in your brain. Now magnify this network scale, expand it further, until each thread spans hundreds of millions of light years. Each node clusters thousands upon thousands of galaxies. This is the true face of the cosmic web, a sculpture carved by gravity upon a skeleton of dark matter. Dark matter, this invisible, mysterious substance, forms the skeleton and filaments of the cosmic web, like steel reinforcement within a colossal edifice. Though unseen, it provides the gravitational framework supporting the entire structure. Upon this invisible skeleton, ordinary matter, those luminous gases and stars, is drawn together by gravity, flowing and coalescing along the filaments of dark matter, ultimately forming the galaxies and galaxy clusters we observe. These luminous galaxies resemble cities and villages lit up across the night sky, distributed along the cosmic highway network, outlining the grand contours of the cosmic web. Within this vast network lie exceptionally dense nodes, often marking the locations of superclusters. For instance, our own Laniakea serves as one such node in this cosmic web. Extending outward from these nodes are slender, elongated filaments of cosmic matter. These filaments can stretch hundreds of millions or even billions of light years, linking disparate superclusters together. Between these filaments and nodes lie vast voids. These cosmic emptinesses are so desolate that within a space of hundreds of millions of light years may contain only a handful of galaxies. This stands in stark contrast to the bustling hubs. This cosmic web, composed of nodes, filaments, and voids, represents the largest known structure in the universe. Its existence demonstrates that cosmic matter distribution is not random, but exhibits a highly organized, network-like structure. The scale of this network is so immense that our observable universe may be merely a finite sample within this infinite pattern. Imagine this scene. Across the observable universe spanning over 93 billion light-years, matter is organized into a vast three-dimensional network, like an infinitely extending cosmic brain. Our Milky Way galaxy is merely a tiny signal at a neural synapse within this brain. The once-thought massive Laniakea supercluster is but an ordinary node in this network. This realization elevates our understanding of the cosmos to new heights. The universe is not a void randomly scattered with galaxies. It is a highly structured entity. Within this entity, from the smallest planetary systems to the largest cosmic networks, all follow the same physical laws. All evolve into hierarchically structured systems under the influence of gravity. When we speak of cosmic scale, the cosmic web represents the current limits of our knowledge. It is the bedrock of cosmic structure, the stage upon which all galaxies and stars form and evolve. To understand the cosmic web is to grasp the very structure of the universe itself, to comprehend how matter organizes itself on the grandest scale. The next time you gaze at the night sky, remember you see not just stars, but a partial projection of a vast network, a tiny fragment of a cosmic structure spanning billions of light-years. This realization makes us feel both insignificant and proud to comprehend such grandeur. Though we are but tiny entities within this web, our minds can embrace the entire network. Perhaps this is the most wondrous miracle in the cosmos. Now we must introduce a crucial concept. It is called the observable universe. This is a key step in understanding cosmic scale, and a concrete manifestation of the limits of our knowledge. First, you must clearly understand that the observable universe is not identical to the entire universe. A fundamental distinction exists between these two concepts. The universe we commonly refer to encompasses the totality of all existing things, including all space-time, matter, and energy. This is a vast concept bordering on the philosophical, whereas the observable universe is a sphere defined by our own observational position and the laws of physics. The center of this sphere is ourselves. More precisely, it is our observation point, Earth. Its radius is jointly determined by the age of the universe and the speed of light. Consider this: the speed of light is finite. The age of the universe is also finite, approximately 13.8 billion years. This means that since the universe's birth, even the earliest photons to depart could travel only a finite distance. This distance is roughly 13.8 billion light-years. But here lies a crucial detail. The universe itself is expanding. Space is continuously stretching. This expansion means that celestial bodies which emitted light in ancient times have now receded far beyond our reach, due to the expansion of space itself. Therefore, when calculating the radius of the observable universe today, it is not simply 13.8 billion light-years, but approximately 46.5 billion light-years. This implies the observable universe's diameter reaches a staggering 93 billion light-years. Imagine this scene: a sphere centered on us, with a diameter of 93 billion light-years. Within this range, all celestial bodies theoretically capable of exchanging information with us are contained, because their light, gravitational waves, or other messengers have sufficient time to traverse the expanding space and reach us here. The boundary of this sphere is not a physical wall. It is not the edge of the universe. It is a boundary of time, a boundary of information, an absolute horizon set by the speed of light and the age of the cosmos. Beyond this boundary may lie more galaxies, more stars, more wonders. But since the light they emit has not yet had sufficient time to reach Earth, they remain forever beyond our field of vision. As far as our current understanding goes, they might as well not exist. This understanding both defines our capabilities and declares our limitations. We are prisoners within the cosmos, imprisoned within a spherical cage woven from time and the speed of light. Everything we can study and discuss is confined solely to the interior of this observable sphere. So the next time you hear the term observable universe, remember it is not an absolute container. It is not a fixed stage. It is more like a spotlight that slowly shifts over time. The range illuminated by this spotlight is our entire world. The infinite darkness beyond the spotlight is the true realm of the unknown. Understanding the concept of the observable universe is the cornerstone for delving deeper into cosmic mysteries. It humbly reminds us that the universe we know is merely a tiny, finite sample of all that may exist. Now let's explore one of the most perplexing questions. Why is the radius of our observable universe 46.5 billion light-years, while the universe itself is only 13.8 billion years old? If the universe began 13.8 billion years ago, shouldn't the farthest distance light could have traveled be 13.8 billion light-years? The answer to this apparent contradiction lies hidden within the universe's most profound property, the expansion of space. Imagine this scenario. You are running on a massive treadmill. Your running speed is constant, just as light speed in a vacuum is constant. But the treadmill itself is sliding backward, and its sliding speed is constantly accelerating. This is the real situation light faces as it traverses the universe. Space itself is this ever-stretching treadmill. Now picture a beam of light departing from an ancient celestial body, shortly after the universe's birth, and beginning its journey toward our present location. At the moment of its departure, that celestial body might have been only a few billion light-years away. This beam of light races toward us at the ultimate speed of 300,000 kilometers per second. Yet throughout its long voyage, the very space beneath its feet continuously expands. Its intended destination, our location, is receding from it due to the expansion of space. It's like crawling along a rubber band that keeps stretching. Though you push forward with effort, the stretching of the band drastically reduces your actual progress. After traversing billions of years of space and time, this beam of light finally reaches our telescopes today. We measure that it has traveled 13.8 billion years. This is its temporal journey. Yet, because space itself expanded during its transit, the total distance it traversed far exceeds 13.8 billion light-years. By precisely measuring the rate of cosmic expansion, astronomers can calculate retrospectively when this light departed 13.8 billion years ago. The celestial body that emitted it was only about 4 billion light-years from us. But over these 13.8 billion years, space has expanded dramatically. That celestial body, once 4 billion light-years away, has now receded to 46.5 billion light-years. This is why the radius of the observable universe exceeds the simple distance corresponding to the universe's age. Light has indeed traveled for 13.8 billion years, but the stage of space it traversed continually expanded beneath its path. This means that by the time it finally reached us, its point of origin had become immeasurably distant. Let's use a more intuitive analogy. Imagine an ant crawling along a rubber band, moving from one end to the other. The ant's speed remains constant, but as it crawls, you continuously stretch the rubber band. When the ant finally reaches its destination, the total length of rubber band it traversed far exceeds the initial distance between the starting and ending points. This is how cosmic expansion operates. The light we receive today from the most distant galaxies originated when the universe was vastly smaller than it is now. These ancient photons traversed an ever-expanding space, bearing witness to the universe's growth. They themselves are living fossils of cosmic expansion. This realization fundamentally reshapes our understanding of distance and time. The universe is not a static stage, but a dynamic, expanding structure. When we observe distant galaxies, we are not merely measuring distances in space. We are reading the history of cosmic expansion. So remember, the observable universe's diameter of 93 billion light-years does not violate the speed of light principle. It is instead the most compelling evidence for the universe's dynamic expansion. It tells us that space itself is elastic, can be stretched. This discovery stands as one of the greatest revolutions in 20th century cosmology. The next time you contemplate the scale of the universe, recall the image of light running on an expanding treadmill. This picture encapsulates the essence of modern cosmology and opens entirely new doors for understanding the past and future of our cosmos. The speed of light is the ultimate velocity for information transmission in the universe. Yet this speed cannot bridge all distances under all circumstances. Because space itself is accelerating in its expansion, there exist regions receding from us faster than light. This is not objects moving faster than light through space, but a consequence of space's own expansion. These superluminal receding regions form the cosmic horizon we can never reach. Imagine standing at the center of an ever-expanding ocean, where the surrounding waters accelerate away from you. Beyond a certain distance, the receding speed of the ocean surpasses any possible wave propagation. Thus, any waves generated from that region, no matter how powerful, can never reach your location. This is the essence of the cosmic horizon, an absolute boundary created by the speed of space's expansion. Beyond this boundary lies a portion of the universe forever beyond our observational reach. There may exist even more bizarre galaxies, more ancient stars, or perhaps supercivilizations that have evolved over billions of years. They may have mastered the ultimate technology to manipulate spacetime, or be creating new universes, or have already solved all the mysteries of existence. But this information will forever remain isolated beyond the horizon, locked away in a vault we can never open. The speed of light is no longer a bridge connecting civilizations, but a barrier isolating information. The radio signals we send into deep space are like stones tossed toward a receding sea, ultimately sinking into the expanding fabric of spacetime, never reaching those distant shores. Even more profound is the realization that this horizon is not static. Due to dark, energy-driven, accelerated expansion, our observable universe is actually slowly shrinking. Distant galaxies visible today will vanish one by one beyond the horizon in the future. As darkness gradually swallows light, our cosmic vision is being eroded invisibly. This realization leads to an unsettling implication. If our cosmic horizon is constantly shrinking, then in the past, it must have been larger than it is now. This means that throughout cosmic history, countless galaxies and civilizations may have vanished forever from our sight. We may inhabit a lonely universe perpetually losing its neighbors. Reversing this perspective, we ourselves may lie beyond the horizon of some ancient civilization, in some corner of the cosmos forever beyond our detection. An archaic civilization born long before the Milky Way formed may have once observed our galaxy's birth. Yet as space expanded, we have long since receded beyond their event horizons. Eternally forgotten, this mutual isolation creates a cosmic-scale solitude, where every civilization is trapped within its own observable bubble, like countless unconnected islands in the ocean, sharing the same universe, yet forever unable to truly meet, forever unable to exchange knowledge, forever unable to jointly confront the ultimate mysteries of the cosmos. This realization makes us feel both insignificant and more appreciative of the finite universe we can observe. Within this gradually shrinking realm of light, every galaxy we can see, every ray of starlight that reaches our telescopes, is a miracle that has overcome countless obstacles to meet us. When we gaze upon the night sky, what we see is not merely twinkling starlight, but precious gifts traversing time and space, sent by cosmic neighbors who have not yet departed from us. This realization makes every speck of light in the night sky seem exceptionally precious, exceptionally worthy of our exploration and understanding. The universe we perceive is, in truth, a vast illusion. All the matter we can see and touch, stars, planets, nebulae, comets, asteroids, and indeed humanity itself along with all life on Earth. All these foundations of our reality constitute only an insignificant fraction of the total mass and energy in the universe. Through the most precise measurements of modern cosmology, we know that ordinary matter, the matter described by the standard model of physics, accounts for a mere 5% of the total mass energy of the universe. This figure implies that everything we can observe, study, and comprehend is but the tip of the iceberg of cosmic reality. Now, consider this number carefully, 5%. This means that out of every 20 fundamental components of the universe, only one is somewhat familiar to us. The remaining 19 are entirely alien entities. Imagine entering a room where 95% of the space is shrouded in thick fog. You can only see the surrounding 5%, and this meager visible portion comprises your entire understanding of the room thus far. This is humanity's true position within the cosmos at present. What constitutes the remaining 95%? They are collectively termed dark matter and dark energy. These concepts may sound like elements from science fiction, yet they represent some of the most robust discoveries in modern cosmology. Dark matter accounts for approximately 27%. Dark energy accounts for about 68%. Together, they constitute the overwhelming majority of the universe. These figures are neither guesswork nor assumptions. They are the result of multiple independent observational methods cross-validating each other. These include precise measurements of the cosmic microwave background radiation, large-scale galaxy surveys mapping the structure of the universe, and accurate determinations of the distances to distant supernova explosions. All evidence points to the same conclusion. The material world we know is merely a supporting actor in the cosmos. Dark matter and dark energy are termed dark, not because they emit faint light, but because they interact with light not at all. They neither emit, reflect, absorb, nor scatter light. They are like ghosts in the cosmos, whose presence can only be indirectly sensed through gravitational effects. This discovery has completely overturned humanity's view of the universe. From ancient Greek philosophers to modern astronomers, we have been studying and analyzing the observable universe, which turns out to be only a tiny fraction of the true cosmos. It's as if we were studying the ocean, yet only noticed the foam on its surface. When we gaze at the night sky, all the twinkling starlight we see, all the beautiful nebulae, all the distant galaxies, all these breathtaking sights, combined, they represent less than 1/20th of the universe's true face. This realization is both humbling and exhilarating, for it means the universe holds countless mysteries yet to be uncovered. That 95% of the unknown may harbor entirely new physical laws beyond our imagination. Next time you gaze at the night sky, remember, the dazzling starry expanse you see is merely the prologue to the true universe. Hidden within that dark cosmic backdrop lie the universe's deeper truths, awaiting future explorers to uncover. Let us begin exploring the dark matter that occupies 27% of the universe. This mysterious substance, though invisible and intangible, has left undeniable gravitational traces throughout the cosmos. The first crucial evidence comes from the rotation curves of galaxies. When astronomers observed the rotational speeds of stars and gas within galaxies, they encountered a perplexing phenomenon. Based on calculations using only visible matter, stars at the outer edges of galaxies should rotate more slowly, much like planets farther from the Sun move more slowly in our solar system. Yet actual observations reveal, whether located near the galactic center or at the outskirts, stars maintain nearly identical rotational speeds. This contradiction can only be resolved by one explanation. Galaxies contain vast quantities of invisible matter, distributed within a massive halo, whose gravitational influence governs the entire galaxy's motion. This constitutes the first solid evidence for the existence of dark matter. The second evidence stems from the gravitational lensing effect. According to Einstein's general theory of relativity, massive celestial bodies warp the surrounding spacetime, causing light passing through to bend, like a lens distorting the image of distant objects. Astronomers have observed gravitational lensing effects produced by numerous galaxy clusters, whose intensity far exceeds what visible matter alone could generate. This indicates the presence of substantial unseen mass within these clusters, whose gravity distorts spacetime, amplifying light from distant galaxies, creating natural telescopes across the cosmos. The third piece of evidence comes from the fine structure of the cosmic microwave background radiation. This residual thermal radiation from the Big Bang serves as a photograph of the universe's infancy. By analyzing its minute temperature fluctuations, scientists can calculate the proportions of various cosmic components. All data points to the same conclusion: a substantial amount of cold dark matter must exist to explain the observed structure of our universe. These independent lines of evidence collectively outline the characteristics of dark matter. It does not participate in electromagnetic interactions, and is therefore invisible and undetectable. Yet it possesses mass, and thus generates gravity. Its movement occurs far below the speed of light, and is thus termed cold dark matter. Dark matter plays a crucial role in cosmic structure. It forms the invisible framework of the cosmic web. In the early universe, dark matter first coalesced into filamentary structures under gravity, forming a vast cosmic network. Ordinary matter was subsequently drawn to these regions of higher dark matter density, gradually forming the galaxies and galaxy clusters we observe today. It can be said that without dark matter, there would be no galaxies, no stars, and no us. Dark matter is like an invisible architect, silently shaping the macrocosmic structure of the universe in the darkness. Its gravity acts as the cosmic glue binding galaxy clusters together, preventing galaxies from disintegrating due to their own rotation, and serving as the invisible hand driving galaxies to coalesce into larger structures. When we gaze upon the beautiful galaxies in the night sky, remember, what we see are merely the actors illuminated on the cosmic stage. The true framework supporting the entire stage lies in the dark matter hidden behind the curtain. Though it never reveals itself, it remains an indispensable protagonist in this cosmic drama. The quest to understand the nature of dark matter stands among the most cutting-edge challenges in modern physics. Laboratories worldwide are striving to capture this elusive particle. This exploration may fundamentally reshape our understanding of matter's essence and unveil the true nature of that 27% of the universe. Until the late 20th century, most astronomers believed cosmic expansion should be decelerating. because gravitational interactions between matter act like cosmic brakes, should gradually slow the universe's expansion. Yet, when we began measuring the history of cosmic expansion, we discovered a fact that shocked the entire physics community. Two independent research teams observed distant type Ia supernovae and arrived at completely unexpected results. These supernovae, possessing constant intrinsic brightness, serve as cosmic standard candles. By measuring their actual brightness and observed brightness, we can precisely calculate their distance from us. Simultaneously, by measuring their spectral redshifts, we can determine how much the universe expanded during the time their light traveled. When scientists compared these two sets of data, they uncovered an astonishing phenomenon. The most distant supernovae appeared significantly dimmer than predicted. This meant they were actually farther away than anticipated. The only explanation was, the expansion of the universe was not slowing down, but accelerating, like a car not only failing to brake, but constantly pressing the accelerator. This discovery completely overturned our understanding of cosmic evolution, and earned its three discoverers the 2011 Nobel Prize in Physics. But the more fundamental question remains: what is driving the universe's accelerated expansion? Scientists refer to this unknown force as dark energy, a mysterious presence permeating all of space. It appears to possess repulsive gravity, the exact opposite of the attractive gravity of ordinary matter and dark matter. It is precisely this repulsive effect that propels space itself into ever-accelerating expansion. According to the latest measurements, dark energy accounts for 68% of the universe's total energy density, making it the dominant force in the cosmos. It not only determines the current rate of cosmic expansion, but will ultimately dictate the universe's final fate. If dark energy maintains its current properties, the universe's accelerated expansion will persist indefinitely, potentially culminating in an ultimate outcome known as the Big Rip. As expansion accelerates, first, the expansion between galaxy clusters will exceed the speed of light, cutting off causal connections between them. Then individual galaxies will be torn apart. Star and planetary systems will disintegrate. Finally, in the last instant before their demise, even atoms and atomic nuclei themselves will be shredded by the expanding space. However, the Big Rip is only one possible outcome. The nature of dark energy remains an unsolved mystery. It may evolve over time and interact with other forms of matter. These uncertainties shroud the universe's future in suspense. The dark energy problem is widely recognized as one of the greatest challenges facing 21st century physics. It compels us to rethink the most fundamental concepts of space-time and the nature of matter. Perhaps behind dark energy lies new physics transcending Einstein's general relativity, or profound mysteries deeply connected to quantum gravity theory. Every time you gaze at the stars, remember, behind that tranquil night sky, a cosmic scale drama unfolds. Dark energy and dark matter wrestle on an invisible battlefield, determining the ultimate fate of all things in the universe. And we live in this dramatic era, able to witness and explore these deepest cosmic mysteries. This is dark energy, a mysterious force propelling the universe's accelerated expansion, a presence that dominates the cosmos yet remains elusive. A pivotal puzzle concerning the universe's ultimate fate. It reminds us that in this universe, what we do not know far outweighs what we do, and the exploration has only just begun. Let us return to the beginning of all things, to the place where all stories began. The universe was not always vast and cold. In the distant past, it existed in an unimaginably hot and dense state. According to the standard model of modern cosmology, Approximately 13.8 billion years ago, the entire observable universe, all space, all matter, all energy, was compressed into an infinitesimal scale. This state is called a singularity, a point where density and temperature approached infinity. Then a creation-like explosion occurred. This is what we call the Big Bang. But don't be misled by the name. It wasn't an explosion at a specific location. Rather, space itself expanded simultaneously in all directions. Like dough rising in a fermentation process, every raisin moves farther apart from every other. In the first instant after the Big Bang, the universe underwent an even more extreme process: inflation. Within a mere 10 to the power of negative 32 seconds, the universe's size increased by at least 10 to the power of 26 times. This expansion far exceeded the speed of light. Yet it did not violate physical laws, because it was the expansion of space's very fabric. The theory of inflation explains many fundamental properties of the universe. Why it is so uniform in every direction. Why its geometry is so flat. Because inflation, like blowing up a balloon, smoothed out all the initial irregularities of the universe, stretching space-time into a nearly perfect flatness. When inflation ended, its immense energy transformed into matter and radiation, creating the universe's initial primordial soup of fundamental particles. At this point, the universe's temperature reached 10 to the power of 27 degrees, filled with quarks, leptons, and photons, like a fiery, dense ocean. As the universe continued to expand and cool, these fundamental particles began to combine, forming the earliest atomic nuclei within the first 3 minutes, a process known as primordial nucleosynthesis, which created most of the hydrogen and helium in the universe, elements that remain the primary fuel for stars to this day. Approximately 380,000 years later, the universe cooled sufficiently for electrons to bind with atomic nuclei forming neutral atoms. At this point, photons could finally propagate freely, forming the cosmic microwave background radiation we observe today. This is the universe's oldest baby photo. Though inflation theory sounds like science fiction, it is supported by solid observational evidence. The tiny temperature fluctuations in the cosmic microwave background exactly match the quantum fluctuations produced during inflation. These minute density fluctuations eventually grew under gravity into today's galaxies and galaxy clusters. Imagine this: every cosmic structure we see today, all galaxies, stars, and planets, originated from quantum fluctuations during inflation. These random ripples at the smallest scale were amplified to cosmic dimensions through inflation, ultimately evolving into the magnificent universe we behold. This realization humbles us and fills us with wonder. The universe is not eternal and unchanging. It had a definite beginning and continues to evolve. From that unimaginably hot and dense state, it expanded and cooled, ultimately forming the conditions that allow life to exist. When we gaze at the night sky, we see not only the present universe, but a magnificent epic spanning 13.8 billion years. And all of this began with that moment of creation known as the Big Bang, and the astonishing inflation that followed. Now close your eyes. Imagine that first instant. Space and time had just been born. The universe was nothing but an infinitely small point. Then it expanded at a speed beyond imagination, creating everything we see today. This idea is both awe-inspiring and calming. Let us drift off to sleep, with reverence for the origins of the universe. We live in a unique cosmic epoch, a golden age known as the stellar era. In this era, the universe is filled with light. Galaxies still contain ample gas and dust to continuously give birth to new stars. In this era, giant molecular clouds collapse under gravity, igniting nuclear fusion reactions at their cores, becoming beacons illuminating the cosmos. Smaller stars like red dwarfs can burn steadily for billions of years, while massive stars, though short-lived, through supernova explosions, scatter heavy elements across interstellar space, providing the raw materials for planet and life formation. Our Sun is a quintessential star, in its prime, steadily radiating light and heat. Within its habitable zone, Earth nurtures a vibrant tapestry of life. This era is precious, because it is neither the primordial chaos of the cosmos, nor its ultimate darkness, but a perfectly balanced point. Yet the stellar age cannot endure forever. Approximately 10 trillion years hence, the universe will reach a turning point. Gas and dust within galaxies gradually deplete, preventing the formation of new stars. This marks the dawn of the degeneration era. During this era, existing red dwarf stars continue to glow, but they too will gradually fade. White dwarfs and neutron stars become the cosmic protagonists. Though these stellar remnants retain residual heat, they possess no new energy source, cooling steadily over time. The universe's overall luminosity begins to significantly diminish. Occasional flashes may pierce the darkness. White dwarfs may accrete material from companion stars, triggering nova explosions, or two compact stars may merge, producing gamma-ray bursts. Yet these are merely fleeting sparks in the cosmos's long night. When the last red dwarf exhausts its fuel, the universe will enter the age of black holes. This era may persist for unimaginably vast timescales, with black holes becoming the sole protagonists on the cosmic stage. Supermassive black holes at the centers of galaxies continue to grow by accreting surrounding matter, but they too will eventually exhaust their fuel. The entire universe will be left with only black holes and scattered interstellar matter. Even these black holes will not exist eternally. According to Hawking radiation theory, black holes slowly evaporate their mass. Smaller black holes evaporate faster. Stellar mass black holes may take trillions of years to evaporate completely, while the evaporation process of supermassive black holes could take as long as 10 to the power of 100 years. This unimaginably vast time span. When the last black hole completely evaporates, the universe enters its final stage, heat death. By this point, the universe will have expanded to unimaginable proportions. All matter will have decayed into its most stable forms, leaving only sparse fundamental particles and photons. Temperature will approach absolute zero. Energy will be uniformly distributed throughout space, rendering any meaningful work impossible. In this ultimate state, no new stars will be born, no galaxies will rotate, no sense of time will flow. The universe becomes a thin, uniform soup. All structures, all changes, all stories become the eternal past. This realization makes us cherish the present moment even more. We happen to live in the universe's most vibrant era. To gaze upon the starry sky, to contemplate the origin and destiny of the cosmos, is itself a rare fortune. Now, please close your eyes. Imagine the universe from its fiery beginning to its icy end, this entire magnificent epic. Then let your thoughts return to the present. In this luminous stellar age, feel this precious gift bestowed upon us by the cosmos. Slowly drift into peaceful slumber. We occupy an extraordinarily unique coordinate on the cosmic timeline. This moment is so exquisitely crafted, as if the universe itself opened a special window for us to observe. Had our civilization emerged in an earlier epoch, say within the first few 100 million years after the universe's birth, the cosmos would still have been in its primordial chaos. The first generation of stars had just begun to form, composed solely of hydrogen and helium. Their burning was intense yet fleeting, unable to form planets rich in heavy elements, much less capable of nurturing life. The universe then was saturated with high-energy radiation, an environment of extreme harshness, fundamentally unsuitable for the formation of complex molecules. Moreover, the early universe was excessively dense. Galaxies collided and merged with alarming frequency. Stellar systems struggled to maintain stability, resembling an unceasing cosmic storm. In such an environment, even if life were to emerge, sustained evolution and development would prove exceedingly difficult, much less contemplate the mysteries of the cosmos with a calm mind. Conversely, imagine if human civilization emerged in the distant future, trillions of years hence. By then, the universe would have entered an era of degeneration. All gas clouds would be exhausted. New stars would cease to form. Existing stars would gradually extinguish. Galaxies would grow dim and lifeless. The cosmic background radiation would continue its redshift. The microwave background would eventually become undetectable. In that dark age, the night sky would no longer sparkle with stars. Other galaxies would have long since receded beyond our field of view. Only the remnants of our own local group would remain within the observable universe. Future astronomers would have no way of knowing the existence of the large-scale structure of the cosmos. They might believe the universe consists solely of their isolated galaxy cluster. All cosmological evidence will vanish forever. We happen to exist at this perfect moment. The universe is sufficiently old for heavy elements to accumulate abundantly, forming the rocky planets and complex molecules necessary for life. Yet it remains young enough that the night sky still sparkles with stars, allowing us to observe the lingering glow of the Big Bang, the cosmic microwave background radiation. We live in the zenith of the stellar age. The Milky Way still teems with rich interstellar medium, constantly giving birth to new stars. The universe's expansion has just begun to accelerate, yet it has not yet torn apart all cosmic structures. We can still observe distant galaxies, study the large-scale structure of the universe, and trace the evolutionary history of the cosmos. This era grants us a unique opportunity. We can detect photographs from the universe's infancy, the cosmic microwave background radiation, observe quasars from its adolescence, and study the formation and evolution of mature galaxies. We possess a complete scroll of cosmic evolution, a precious perspective unavailable to earlier civilizations, and forever lost to future ones. Our position is not spatially privileged, but we are exceptionally fortunate in time. This may be the universe's finest gift to contemplative minds. In this perfectly timed epoch, we can both comprehend the cosmos's workings and marvel at its grandeur, trace its past, and contemplate its future. Let us cherish this golden window. In this extraordinary era, we are not merely observers of the universe, but its eyes for self-reflection, its brain for self-contemplation. Now carry this awareness into peaceful sleep, knowing we stand at a fleeting yet priceless moment in the cosmos's vast history, a perfect instant where thought itself becomes possible. Take a deep breath. Feel the air filling your lungs. The oxygen atoms you just inhaled were forged in the fiery core of a massive star. Now place your hand over your heart. Feel the rhythm of your pulse. The iron in your blood that carries oxygen was born in an ancient supernova explosion, a cosmic fireworks display brighter than entire galaxies. Raise your hand and examine it closely. The calcium that builds your bones, the potassium and sodium that transmit signals through your nerves, the phosphorus that forms the backbone of your DNA, all share the same resplendent origin. born in the cosmic cycle of stellar life and death. Let us trace the cosmic journey of these atoms. Most of the hydrogen atoms in your body are among the universe's oldest inhabitants. They existed shortly after the Big Bang and have drifted for nearly 14 billion years. Heavier elements tell a different story. Carbon and oxygen primarily formed within sun-like stars, through gradual accumulation via nuclear fusion reactions. These stars spent billions of years, cooking the elements essential for life within their tranquil cores. The birth of the iron in your body tells a more dramatic tale. Iron can only be forged in stars more than 8 times the mass of the sun, through the silicon burning process. When such a star exhausts its fuel, this core collapses in 1/10 of a second, triggering a spectacular supernova explosion. In this most violent cosmic event, iron is hurled into interstellar space. Elements heavier than iron, like gold and uranium, require even more extreme conditions for their formation. They may originate from neutron star collisions, the remnants of 2 dead stars orbiting each other before merging. The immense energy released in that instant is sufficient to forge the heaviest elements. These elements mix within interstellar gas clouds, gradually enriching over time. When a new generation of stars and planets forms, they become integral components of these emerging systems. Approximately 4.6 billion years ago, on an ordinary spiral arm, a gas cloud rich in these heavy elements began to collapse, forming our sun and the planets orbiting it. During Earth's formation, these stellar gifts became components of our planet. After billions of years of evolution, these atoms combined in wondrous ways, forming life capable of thought, forming you who are reading these words. This means every atom in your body has journeyed across cosmic distances. They endured infernal heat within stars, were scattered in supernova explosions, drifted through interstellar space for millions of years, and finally found their home on Earth, to compose the you who contemplates the universe. This is not poetic imagination, but rigorous scientific fact. The 1957 B2FH paper detailed the process of element synthesis within stars, named after the initials of 4 physicists. This paper laid the foundation for modern astrophysics. So when you say we are children of the stars, it is not merely a beautiful metaphor, but a physical reality. Every breath we take bears the imprint of stars. Every cell in our bodies carries the history of the cosmos. This realization transforms our relationship with the cosmos. We are not accidental strangers in the universe. We are part of the universe's own evolution, the awakening of stellar matter after its long journey. The cosmos does not operate indifferently beyond us. It flows through our blood, beats within our hearts, and flickers within our thoughts. When you gaze at the stars, you are not an outsider observing an alien realm, but a fragment of the cosmos gazing back at itself. Stellar matter contemplating its own origins. This profound sense of connection may hold the key to understanding the universe. We are made of cosmic matter, and thus inherently possess the potential to comprehend it. Next time you look up at the stars, remember, those distant points of light are not strangers to you. They are your homeland, the birthplace of the atoms within your body, a kinship spanning time and space. Now carry this awareness to sleep, knowing you are a miniature universe, carrying the weight of billions of years of history. And all of this will continue whispering in your dreams, telling of the eternal kinship between us and the stars. When you first see a visualization of the cosmic web, it's hard not to feel a strange sense of déjà vu. Those galaxy clusters, nodes connected by filaments of dark matter, extend intricate patterns against the deep cosmic backdrop. Now, find an image of the brain's neural network. Place the two side by side. This comparison will take your breath away. The largest scale structure of the universe and the minutest structures of the human brain reveal astonishing morphological similarities. Within the brain, neurons connect through axons and dendrites, forming intricate networks to process information. Neurons themselves cluster at nodes, communicating via filaments of nerve fibers. Electrochemical signals traverse synaptic gaps. Across the cosmos, galaxies interconnect through filaments of dark matter, forming colossal structures spanning hundreds of millions of light-years. Clusters of galaxies themselves gather at nodes, linked by filaments of matter, through which gravitational interactions propagate. This similarity is more than a visual coincidence. Scientists have quantitatively studied this correspondence, comparing structural parameters of the cosmic web and brain neural networks, including node count, connectivity, clustering coefficient, and more, finding them statistically comparable. This cross-scale similarity raises a profound question. Why do structures from microscopic neural networks to macroscopic cosmic frameworks spontaneously adopt this networked morphology? One possible explanation stems from fundamental principles of physics. These systems all pursue minimal energy expenditure. Network structures represent the optimal solution for efficient connectivity under constraints, just as river networks, lightning paths, and even human transportation systems tend to form similar topological configurations. Another perspective is more radical. Perhaps this similarity hints at a deeper organizing principle. The universe may follow the same construction principles across all scales. From the quantum world to galaxy clusters, there exists a universal mechanism for network formation. This leads us to ponder: if the brain can generate consciousness, then might the cosmological web with its similar structure also possess some form of cosmic consciousness? Though this question lies beyond the scope of current science, it warrants an open-minded approach. It is important to note that this similarity does not imply a one-to-one correspondence. The scale of the cosmic web is billions of times larger than that of the brain, and its evolutionary timescale is entirely different. Yet, it is precisely this repetition of patterns across scales that offers new insights into the unity of nature. Perhaps the answer lies somewhere between coincidence and revelation. Network structures are indeed the result of self-organization in complex systems, but this very universality reveals the deep mathematical laws present in the cosmos. Fractal geometry has already demonstrated how simple mathematical rules generate complexity across scales, from fern fronds to coastline contours. Now we observe the same complexity unfolding in cosmic structures and brain architecture. This realization both humbles us and reveals a profound cosmic connection. The very brain we use for thought shares such striking internal structure with the macrocosm. This may not be coincidence. When we study the cosmos, we are not merely exploring an external objective reality. We are also using the very mental framework the universe has given us to understand the organizing structure of the universe itself. This is a wondrous form of self-reference. Now, please close your eyes. Imagine each of your thoughts as a flash within the cosmic network. Each thought you have recreates the macrocosmic structure of the universe on a micro scale. Let this realization guide you into peaceful sleep, knowing that you yourself are one way the universe contemplates itself. We have arrived at the frontier where science and philosophy meet, a realm holding the deepest mysteries of consciousness's nature. Traditional science views consciousness as an emergent phenomenon, when matter organizes itself in sufficiently complex ways. Consciousness naturally arises, much like water assumes a liquid state under specific conditions. Yet this explanation faces a fundamental challenge. We still cannot comprehend how purely physical processes generate subjective experience, why specific arrangements of atoms, carbon, hydrogen, oxygen, nitrogen, give rise to feelings of love, experiences of beauty, or contemplations of infinity. This is known as the hard problem of consciousness. Against this backdrop, an ancient idea has regained attention: panpsychism. This theory proposes consciousness is not a complex product of matter, but an innate fundamental property of the universe, as ubiquitous as mass or electric charge. According to this view, consciousness is not a miracle suddenly appearing at some stage of evolution, but a fundamental fact ever present in the cosmos. From elementary particles to galaxy clusters, all matter possesses some degree of primordial consciousness. This may sound like philosophical fantasy, but note, some distinguished modern scientists and philosophers are taking this possibility seriously, including Nobel laureate Roger Penrose and philosopher David Chalmers. Their arguments rest on solid scientific observations. Quantum mechanics has shown us that the act of observation alters the state of physical systems. A profound connection exists between consciousness and the physical world, one we have yet to understand. If panpsychism is correct, our understanding of the universe requires a fundamental transformation. Consciousness is no longer an accidental byproduct of the universe's late evolution, but a fundamental thread woven into the fabric of the cosmos from the very beginning. This implies that when we study the universe, we are not merely examining an objective material world, but also exploring manifestations of a universal consciousness. The physical laws of the universe may simultaneously be the laws governing the expression of consciousness. Re-examining the vastness of the universe from this perspective yields a wholly new understanding. The cosmos is not only infinite in space and time, but equally boundless in the dimension of consciousness. Every galaxy, every star, every planet may participate in some way in the cosmic symphony of consciousness. Human consciousness is no longer a solitary miracle, but a particular expression of the universe's universal consciousness. Like waves in the ocean, it is a transient form of the ocean itself. This view does not diminish the value of human consciousness. On the contrary, it imbues our existence with deeper meaning. We are not accidental strangers appearing in an indifferent cosmos. We are the universe's means of knowing and understanding itself. When you contemplate the scale of the universe, this realization brings a wholly different sensation. The immensity of the cosmos no longer evokes fear or alienation, for it is, at its core, the immensity of consciousness. Between us and distant galaxies, we share not only the same physical laws, but potentially a profound foundation of consciousness. This understanding may explain why the human mind comprehends the mathematical laws of the universe, and why we resonate so deeply with the starry sky. For in the deepest sense, we are one with the cosmos, the various theories modern physics is exploring, from quantum gravity to string theory, may all have profound connections to the nature of consciousness. Perhaps the ultimate theory of everything will not only unify all physical forces, but also incorporate consciousness into its framework. This places us on the eve of a scientific revolution, much like the people of Copernicus's era, who were about to discover Earth was not the center of the universe. We may soon discover that consciousness is not a local phenomenon of life's evolution, but a fundamental characteristic of the cosmos. Sleep with this awareness. Know that every dream you dream is a ripple in the cosmic sea of consciousness. Your very existence is a way for the universe to contemplate itself. In this infinitely vast cosmos, you are never alone, for consciousness binds all things into a single whole. In the fleeting moment of the universe's birth, the inflation process may not have ceased uniformly. According to theories by some leading cosmologists, inflation may be eternal on a cosmic scale. When inflation ceases in one region, it forms a bubble universe like ours. Meanwhile, inflation persists in other regions, continuously creating new spacetime. Imagine a pot of water perpetually boiling. Each rising bubble represents an independent universe. Each bubble draws energy from the inflationary field, experiencing its own Big Bang, and embarking on an independent evolutionary journey. This is the picture painted by the eternal inflation theory, an unceasing mechanism for cosmic creation. These bubble universes may exhibit fundamental differences in their physical properties. As they separated from the parent inflationary field, they underwent distinct symmetry-breaking processes, resulting in varying fundamental physical constants. The finely tuned constants in our universe, such as the gravitational constant, the strength of the electromagnetic force, and the masses of elementary particles, may be entirely different in other bubble universes. In some universes, gravity might be far stronger than ours, causing stars to rapidly collapse into black holes before life could evolve. In others, the electromagnetic force might be too weak for stable atoms to form, leaving matter existing only as plasma. Even the number of spatial and temporal dimensions could vary. We inhabit a four-dimensional spacetime, while other bubble universes may possess additional spatial dimensions, or multiple temporal dimensions. The physical laws governing these universes would surpass our wildest imaginings. Each bubble universe constitutes an independent reality, with its own history, its own laws of physics, its own possibilities and impossibilities. Separated by ever-expanding space, they remain forever incommunicado, like distant islands in the ocean. This theory is not purely philosophical speculation. It naturally emerges from the mathematical framework of inflationary theory. Developments by physicists like André Linde have made it a plausible explanation for our universe's uniqueness. If this picture is true, then our universe is merely an ordinary member of the multiverse. The specific physical constants we observe exist only because such constants allow the evolution of observers capable of posing this question. This is the profound manifestation of the anthropic principle. We exist within this particular bubble, not because it is special, but because only under such physical conditions could life and consciousness arise. Within this infinite multiverse, countless versions of reality may exist, some barren and simple, some rich and complex, some even beyond the boundaries of our logic. When we gaze at the night sky, what we see may be just one of countless realities, while in other bubbles forever beyond our reach, completely different cosmic narratives unfold. Now let this thought carry you into sleep. In this endless ocean of cosmic creation, our world is but a fleeting bubble. Yet within this bubble arose consciousness capable of contemplating all this. This itself is a beautiful miracle. If the multiverse is infinite, and the laws of physics differ in each universe, then a startling implication follows. Every logically possible history and event must be unfolding in some cosmic bubble. On this infinite stage, every possible version of you truly exists. In one universe, you chose a different breakfast this morning. In one universe, you chose a different university. In one universe, you prevailed in the chance you were never born. In one universe, you became an astronaut, now flying toward distant stars. These are not fictional tales of parallel timelines, but mathematical inevitabilities based on infinite probability. As long as the possibility is not zero, it will manifest in an infinite sample, and manifest infinitely many times. This raises profound questions about free will. If every version of every choice is realized, does choice itself retain the meaning we imagine? Perhaps free will lies not in forging a unique path, but in experiencing the scenery along this particular journey. The implications for identity are equally profound. When infinite versions of you coexist, can you still consider yourself unique? Perhaps individuality is an illusion, each of us merely a facet of infinite existence. This does not diminish the value of our existence. Rather, it places it within a grander context. The moment you are experiencing now, whether joyful or painful, successful or failed, is a precious expression among the universe's infinite possibilities. From this perspective, regret loses its sharp edge, for every path not chosen is being lived by another version of you somewhere. You need not lament what you missed. Simply immerse yourself in the uniqueness of your own journey. The meaning of life is thus redefined. Meaning lies not in creating the one true life, but in deeply experiencing the journey of this particular timeline. Like reading a single chapter from a book of infinite possibilities, the value of this chapter isn't in its uniqueness, but in how you understand and feel it. This fosters a profound new reverence for reality. Every seemingly ordinary moment is a pearl in the ocean of infinite possibilities. Every breath, every smile, every choice plays a unique role in the universe's infinite theater. Tonight, as you prepare to sleep, let this thought soothe your soul. Knowing in the infinite cosmos, you are both special and not special. The path you chose in life is precisely one worth experiencing among infinite possibilities. In this vast multiverse, no path is truly wrong, for every path has been walked, nor is any choice absolutely right, for every choice has been made. Your only task is to fully experience this unique path that is yours, to discover within it your own meaning and beauty. Now let this realization guide you into peaceful sleep. In dreams, you may encounter other versions of yourself, sharing the taste of different choices. If technological progress in a civilization has no fundamental limits, then a highly advanced civilization will eventually master unimaginable computational power. This capability might be sufficient to simulate every detail of the entire universe, including every conscious being within it. Such a simulated universe would appear completely real to its inhabitants. They would be unable to perceive they live in virtual reality, for their senses and physical laws are meticulously constructed by code. From a statistical perspective, if such simulations are technically feasible, it is highly probable that numerous simulated universes already exist. The quantity of simulated universes may vastly exceed that of the base reality. This leads to a startling implication. The probability of our existence in the base reality is actually extremely low. It is far more likely we are merely a line of code within a simulation program run by an advanced civilization. Though this hypothesis sounds like science fiction, some scientists and philosophers are seriously exploring it. Elon Musk has publicly stated multiple times that we almost certainly live in a simulation. Arguments supporting this view include: the physical laws of our universe exhibit remarkable mathematical regularity, resembling a meticulously designed code architecture. The observer effect in quantum mechanics also evokes rendering techniques employed to conserve computational resources. But the truly perplexing question is whether we have any means to definitively prove we aren't in a simulation. Any detection method we might devise could itself be part of the simulation, much like a game character unable to jump out of the screen to inspect the host computer. If we gather seemingly conclusive evidence proving this is a simulation, could be an Easter egg deliberately planted by the program. If we prove it isn't a simulation, that conclusion itself might be pre-programmed. This realization plunges us into a philosophical conundrum. We may never know the answer, much like a goldfish cannot comprehend the world beyond its bowl. We may remain forever confined within the boundaries of our perception. Yet perhaps the answer itself is irrelevant, whether we inhabit foundational reality or an intricate simulation. The love and beauty we feel, the pain and joy we experience, the meaning and value we pursue, remain undiminished. The curiosity you feel as you read these words now, the focus you bring to pondering this question, are equally real regardless of which reality we inhabit. Now, let this open-ended question accompany you to sleep. Seek no definitive answer. Simply savor the wonder of the thought itself. In this universe, whether virtual or real, your conscious experience is the most precious gift. We set forth from this familiar planet. Begin imagining from the garden outside your window. Watch the city beneath your feet gradually blur in your vision. Earth transforms into a suspended blue gem in the darkness. We soar through the suffocating emptiness of the solar system, where a basketball-sized sun reigns over kilometers of void. We traverse the vast chasms between stars, where the nearest neighbor requires light to journey 4 years. We enter the Milky Way, this city of stars, where hundreds of billions of suns rotate slowly within. We discover galaxy giants dwarfing our own, possessing trillions of stars spanning millions of light years. We witness how galaxies cluster together, forming superclusters spanning 500 million light years. We behold the grand structure of the cosmic web. Dark matter filaments connect countless galaxies like a neural network. We reached the edge of the observable universe, a sphere 93 billion light years in diameter, only to discover it defines merely a horizon set by light speed. Beyond it lies potentially infinite unknowns. We confronted the mystery of the universe's composition. Finding the familiar makes up just 5%. The rest is unseen dark matter and dark energy. They govern the cosmos' destiny. We traced the universe's origin and end, from the fiery Big Bang to the cold heat death, discovering we live precisely in the universe's golden age. A precious moment when we can both understand and appreciate the cosmos. We contemplated the profound connection between consciousness and the universe, discovering every atom within us originated from dying stars. We may be the universe's way of knowing itself. We finally crossed the boundaries of reality, into the infinite realms of the multiverse, where every possible universe exists somewhere, and every possible version of you experiences different lives. Now, as we look back on this journey, from the tiniest beginnings to the most vast distances, every scale is awe-inspiring. Every leap reshapes our understanding. Let these images now gently flow through your mind, as serene and timeless as the rhythm of the cosmos itself. With awe and humility for the vast universe, slowly drift into peaceful sleep. In the infinite theater of the cosmos, we must first acknowledge an inescapable truth. On the physical scale, we are countless times smaller than a speck of dust. Earth is but a speck of sand within the solar system. The solar system is merely a faint speck within the Milky Way. The Milky Way is just an ordinary spiral galaxy within the cosmos, and the observable universe itself may be but a tiny bubble within an infinite reality. This realization should plunge us into despair. Yet here lies a wondrous paradox. It is precisely these beings, forged from stardust, who possess the capacity to gaze back at the cosmos and comprehend its vastness. We can measure distances in light years, trace the origins of the universe, understand the physical laws governing galaxies, and contemplate the essence of existence. This ability grants us a unique position in the cosmos. We are not merely components of the universe. We are the universe's means of self-recognition, the vessel through which the cosmos contemplates itself. Every time you gaze up at the stars, it is not merely an act of observation. It is the universe looking back at itself through your eyes. Every time you marvel at cosmic scale, it is not just an emotional expression. It is the universe contemplating its own immensity through your consciousness. We are finite beings, yet capable of grasping infinite concepts. We are transient existences, yet able to ponder eternal meaning. We are minuscule individuals, yet able to embrace the entire universe. This dual identity makes us both humble and sublime, both insignificant and magnificent. We know our physical place in the cosmos, yet we also know we play an irreplaceable role in the journey of understanding the universe. Now embrace this dual identity. As stardust, you are small. As the mind of the universe, you are sublime. Let this awareness bring you peace and strength. Knowing your very existence is a miracle of the cosmos. Beneath this boundless starry sky, you are both spectator and performer, both student and teacher, both explorer and the mystery itself. Good night. May you drift peacefully to sleep, in the embrace of the stars. Now take a deep breath. Feel the breath flowing into your body, then exhale slowly. Let all thoughts begin to settle. Gently bring your attention back, from the infinite depths of the cosmos, to this quiet room. Feel your body touching the chair. Notice the air moving around you. Tonight we traversed astonishing scales, from Earth's home to the edge of the cosmos, from the material world to the realm of consciousness. This journey transcends imagination. At the journey's end, let us remember the most vital discovery. We are indeed fleeting aggregates of stardust, ultimately returning to the cosmic cycle. Yet simultaneously, we are also the universe's means of self-recognition. Eyes gaining reflective capacity amidst the vast sea of stars. Nodes acquiring the power of thought within infinite spacetime. This realization grants us dignity within our smallness, and reveals eternal meaning within our transience. We are both fleeting sparks, and the light illuminating the cosmos' self-awareness. Now let this understanding accompany you. Release all thought. Release all concepts. Simply feel the stillness and wonder of being. Let these cosmic vistas settle gently like stardust into the background of your tranquil dreams. Good night. May you remember in the stars' dreams that you are a way for the universe to contemplate itself. Let sleep embrace you softly. In this quiet corner of the boundless cosmos, rest peacefully,